In this video, we're going to be looking at polyatomic ions, that is, ions with more than one atom. How these arise is that we usually have a molecule or a compound where one of the atoms has been removed or an extra atom has been added, and so we're left with the species that has an overall charge. So I'm going to go through first. There's only a couple of positive ones, but there's quite a few negative ones that you need to learn off for the course. It is really worth knowing these species because they get involved in most of the chemical reactions. It's also really worth knowing how to form a chemical formula of a compound which has a polyatomic ion within it. So the first one is the ammonium ion. Ammonium ion exists where you have an ammonium molecule whose lone pair has been used in a dative covalent bond with a hydrogen ion to form overall the ammonium ion, NH4+. Hydronium ion we came across before in the acids topic. This is where we just have a water molecule whose lone pair is used with the hydrogen ion to form H3O+. The next ion we come across are the negative ones where we have a hydroxide ion. How does this form? Well, if we look at the water molecule, water we know partially dissociates into its ions, H+ and OH-. That is, the pair of electrons here that are in this bond simply jump onto the oxygen and you've got an extra pair of electrons, which is why you have a negative charge. That's called a hydroxide ion. Next ion is the nitrate ion. This is formed from nitric acid, so when nitric acid dissociates, you're left with the nitrate ion. Really common ion that's found in most salts. Again, the nitrogen atom itself is just bonded to oxygens, and we have 3 oxygens, 2 of which have double bonds and 1 of which doesn't have a bond. That's the nitrate ion there. In nitric acid, that oxygen here is bonded to a hydrogen atom. The next ion is the carbonate ion, really common in things like calcium carbonate, which is just another name for limestone effectively. The carbonate looks like this. You've got a carbon bonded to oxygen atoms like that. 2 of the oxygen atoms are oxygen ions because their hydrogens have been removed. If the hydrogen was still there, we'd call it carbonic acid. Now, it turns out when carbonic acid doesn't lose both hydrogens, just has one of the hydrogens removed, let's say from here, we have what's called a hydrogen carbonate ion, H3O-. Next one we come across is phosphate. Acid associated with phosphate is phosphoric acid. Don't mind the shape of that there, but we've got a phosphorus with 4 oxygens around it. 3 of those oxygens have a negative charge. Acid associated with a phosphate is phosphoric acid. What I mean by that is when I have phosphoric acid, H3PO4, and I dissolve it in water, I get the phosphate ion and 3 H+. The next ion to learn off is the thiosulfate ion, really common in some of the reactions, specifically with rates of reaction. It reacts with hydrochloric acid and a precipitate of sulfur. So when you're doing a rates reaction and you want to time a reaction for completion, you can use a thiosulfate. The next one is permanganate. We'll come across that quite a lot in redox titrations. Potassium permanganate, very distinctive purple color. That's MnO4- is the manganate ion, or permanganate, also known as manganate 7 because of the oxidation number on the manganese ion. And the last one we come across is dichromate. Dichromate's a toxic substance, so it used to be used all the time in labs, especially to see the equilibrium reactions involving dichromate and chromate ions. You do find chromate in certain alcohol testings because it's used to oxidize alcohols with a distinctive color change, going from orange to green as you oxidize the ethanol to ethanol. So they are all the polyatomic ions, just to recap them there. And effectively what you need to do is you need to learn them off. You don't need to learn the structures of them at all, you just need to know the chemical formula. The reason for that is when it comes to balancing chemical reactions and things like that, they're really useful. There's also tests for ions which you just basically need to learn off. Okay. Now we're going to go back to creating chemical formula. Remember, the most important thing about balancing equations is you get the chemical formula right first. So, lithium sulfate, what we always do is to start with, write down the lithium ion. We know lithium's in group 1, so it's Li+. Then we go on to our negative ion. We know it's a sulfate, so we look back up for sulfate. It's SO4 2-. So I'm going to write SO4 2-. Now when we were creating a chemical formula, what we wanted to know is the charge on each ion, and we wanted to make those charges equal but opposite. So we have a lithium plus ion here. That means this lithium has to give away one electron when it reacts. We know that's because it's in group 1. Sulfate, SO4 2- is formed by gaining 2 electrons, the SO4 2-, as it's got a 2- charge. Therefore, we need to have 2 lithiums for every sulfate. So the formula for that is Li2SO4, just like that. And that's how we write it. Now we're going to look at a more complicated one. So I'll write down my positive ion, it's the ammonium ion, NH4+. Then I'll write down my phosphate ion, which is PO4 3-. So we look at the charges again. I've got a 1+ and I've got a 3-. So if I want my charges to be equal but opposite, I'm going to need to have 3 ammonium ions. Now whenever you have to put an ammonium ion or polyatomic ion, and you have to have more than one of them, you just put brackets around it. So NH4, we never separate the NH4. We leave it like that, but we need 3 of them because we've only got a plus charge on each of them. So it becomes NH4 3, and then the remaining one is just PO4, like that. Sometimes you might see a dot in between, but it's not necessary. So that's our ammonium phosphate formula. Next we'll look at potassium dichromate. Same strategy. Lithium is in, we're not looking at lithium. Potassium is in group 1, so it's just K+. Dichromate is here, Cr2O7 2-. Remember, we don't do anything with the atoms themselves, we just leave them as they are. We know that we've got a K+ and a Cr2O7 2-. We forget about the lower numbers here, but we've got a plus and a 2-, so therefore I'm going to need 2 potassiums. Formula will be K2 Cr2O7. So the advice is just keep practicing those, learn off the chemical formula for the polyatomic ions, really important, and just practice the formulae.